Welcome to today's tutorial, where we'll be looking at the time series and date functionality in Pandas. Pandas has four main time-related classes: timestamp, datetime index, period, and period index. First, let's look at timestamp. Timestamp represents a single timestamp and associates values with points in time. For example, let's create a timestamp using a string 9/1/2016, 10:05 a.m. And here we have our timestamp. Timestamp is interchangeable with Python's datetime in most cases. Suppose we weren't interested in a specific point in time, and instead wanted a span of time. This is where period comes into play. Period represents a single time span such as a specific day or month. Here we are creating a period that is January 2016. And here's an example of a period that is March 5th, 2016. The index of a timestamp is datetime index. Let's look at a quick example. First, let's create our example series, T1. We'll use the timestamp of September 1st, 2nd, and 3rd of 2016. When we look at the series, each timestamp is the index and has a value associated with it. In this case, A, B, and C. Looking at the type of our series index, we see that it's datetime index. Similarly, the index of period is period index. Let's create another example series T2. This time, we'll use the values D, E, and F, and match them with the periods September, October, and November 2016. Looking at the type of the TS2 index, we can see that it's period index. Now, let's look into how to convert to datetime. Suppose we have a list of dates as strings. If we create a data frame using these dates as the index and some randomly generated data, this is the data frame we get. Looking at the index, we can see that it's pretty messy, and the dates are all in different formats. Using Pandas to datetime, Pandas will try to convert these to datetime and put them in a standard format. To datetime also has options to change the date parse order. For example, we can pass in the argument day first equals true to parse the date in European date format. Time deltas are differences in times. We can see that when we take the difference between September 3rd and September 1st, we get a time delta of 2 days. We can also do something like find what the date and time is for 12 days and 3 hours past September 2nd at 8:10 a.m. Next, let's look at a few tricks for working with dates in a data frame. Suppose we want to look at 9 measurements taken bi-weekly every Sunday, starting in October 2016. Using date range, we can create this datetime index. Now, let's create a data frame using these dates and some random data and see what we can do with it. First, we can check what day of the week a specific date is. For example, here we can see that all the dates in our index are on a Sunday. We can use diff to find the difference between each date's value. Suppose we wanted to know what the mean count is for each month in our data frame. We can do this using resample. We can use partial string indexing to find values from a particular year or from a particular month. Or we can even slice on a range of dates. For example, here we only want the values from December 2016 onward. Another cool thing we can do is change the frequency of our dates in our data frame using asFreq. If we use this to change the frequency from bi-weekly to weekly, we'll end up with missing values every other week. So let's use the forward fill method on those missing values. One last thing I wanted to briefly touch upon is plotting time series. Importing matplotlib pyplot and using the IPython magic matplotlib inline will allow you to visualize the time series in the notebook. In the next course, we will learn more about understanding and creating visualizations. Thanks for watching. See you next time.